Hello, Math Knights. This is Ron Martiello, and recently I have been doing a lot of talking about a specific algebraic concept that can really help students to make sense of problem solving and make them better problem solvers. Because here on Math Knights, we want students not just to solve problems, we want them to conquer those problems. And many times, as they are trying to solve word problems and they see them in all different ways, there are some tools here that we can utilize to help make them better problem solvers. And the way we're going to help them to make sense of those problems and persevere through them is through the situation types. Now, there are 6 situation types when it comes to word problems. There are addition and subtraction situation types and multiplication and division situation types. When we talk about situation types, we want to present these types as a way of thinking flexibly about the problem. Many times we take a look at the specific language of the problem and looking at trick words, and students think of the word problem in a linear fashion. However, we want to instill some flexible thinking with problem solving, and we want students to adapt to the different ways that word problems are presented to them. If you take a look at the standards of mathematical practice, SMP1, SMP2, and SMP3, the first mathematical practice is making sense of problems. We want students to be able to make sense and persevere through. Sometimes we put the perseverance before the making sense. These situation types can definitely help students make sense of the word problem. In standard math practice number 2, or SMP2, students are asked to reason quantitatively and abstractly, which means, what does the problem say in context, in the real world, and then how do we decontextualize with the math, which the situation types can help them make that jump from the context of the problem to the mathematical concepts, and then be able to take the mathematical concepts and come back to contextualizing their efforts in relationship to the problem. The third mathematical practice is creating a viable argument. Many times students solve word problems and they don't know how they got the answer or why they got the answer, and that's an assertion, that's not an argument. When students don't know how they came to a solution, they are only asserting their answer. But when they utilize these situation types and create models to justify their arguments, they definitely have a stronger argument and are able to make connections to the work of others, which again is part of standard mathematical practice number 3. These situation types can be building blocks for problem solving, not just for one-step problems, but for two-step problems. You'll find that as we have our talk, students will encounter problems that may have a situation in the first part of the problem that's different from the second part of the problem. So they may have to add and subtract in the first part of the problem, and then they may have to multiply or divide in the second, or vice versa. These situation types will help students to build a plan to solve those problems, whether it's a one-step problem or a two-step problem. And finally, these situation types are written in the standards from kindergarten through 4th grade under the reporting category or the diagnostic category of algebraic concepts. So make sure that you're utilizing the language of the standard when referring to these situation types. One resource that I love to use is Achieve the Core, and they have 2 handouts that you could print out, and it's a matrix. The first one is based on the additive situation types, which deal with addition and subtraction. And the second page or resource they have are the multiplicative situations that deal with multiplication and division. Let's explore these situation types one at a time and what the expectations are for students and how they can each help them to become better problem solvers. We're going to get started with our first situation, and this is an additive situation where we are joining and separating. This is a type of addition and subtraction. So when we have a set of objects and we put them together or we take them apart, And so sometimes they can be called joining and separating. Some books or documents will call them put together, take apart. In either case, it's the same thing. We have a set of objects and we separate them into two parts, or we put the two parts together to make the total. There are three positions in this type of problem. And when I talk about positions, I'm talking about what is the unknown number that students need to solve for, because sometimes it's not always the total. Students think very linearly when they have a more traditional math background, and they always think that they're solving for the total, which is why they always take two numbers and then do something with them, and their thinking might not be quite accurate and precise. So we need to talk about the three positions. In this type of problem, we have a total. We also have two addends, which are the two parts. And so sometimes we could be solving for the total, and sometimes we could be solving for a single addend, and sometimes we'll have a total, but there are two missing addends. And that's a more open type of problem where students can use that flexible thinking on how to make a total. We want to be able to solve for all positions, but also write up equations, related equations, with a symbol for the unknown. And I'll get into that in a second. First, let's explore what this problem might look like. There are 10 apples altogether. 4 are green. How many are red? Sometimes when we use trick words like altogether, or we try to have students find those trick words like altogether, students automatically think addition. But if you look at this problem, they give you the total first. There are 10 apples altogether. 4 are green. 4 is one of our addends. They're asking you how many are red, so we have a missing addend. Again, students may get tricked up here if they think linearly and that they're always solving for a total rather than a position in the problem. When solving for these, we can utilize related equations. So in this case, in this situation, I am going to say 10 minus 4 equals question mark, because part of the standard in these algebraic concepts talk about putting a symbol for the unknown number that you're solving for. Students can also enter this problem through addition by saying 4 plus question mark equals 10. It's important that you allow students to think flexibly when writing up these related equations. It's also important that they put a symbol for the unknown number, and then also ask students to explain their reasoning. Sometimes this isn't a matter of getting the answer right. We really want to see what their understanding of this situation is. You want to ask them, what position are we solving for? What is the related equation? And then what does that unknown symbol, or that symbol for the unknown number, really mean? And then how did that lead them to the solution? And that is a way that students can make sense of that problem, and they could also create a viable argument rather than just an assertion. So that is the joining, separating type of problem. So here's another situation. This is called the add to, take away situation. There are 3 positions in this situation. There's a start number, a change number, and a result. Unlike the joining, separating type of problem, there isn't a set. You have a start number, and then that number changes in the middle of the problem, which ends up with a different result. Let me give you an example of this type of problem. There are 10 birds in the tree. Some flew into the tree. Now there are 15 birds in the tree. How many birds flew into the tree? Upon first glance, you may have students try to add 10 plus 15 because they're trying to add the start number to the result. But you can see that the change number is the one that is missing. And what does that change look like? Is that a takeaway, or is that an add to? These are the types of questions that you could be asking your students as they try to analyze the problem type and what position they're solving for. So there are 10 birds in the tree. Some flew into the tree. Those birds that flew into the tree, we're definitely going to talk about how that's addition, and the change number needs to be added to the start number, which will give you the result of 15. The ways that you can represent this through related equations: 10 plus question mark equals 15. Or students can start backwards and start with subtraction. 15 minus a question mark equals 10. Or they could solve it in another way, saying 15 minus 10 equals a question mark. Ultimately, we want to solve for the question mark, which is the unknown number. But that flexible thinking and utilizing operations to come to a solution based on the situation and what position they're solving for is incredibly important. Comparing situations can be very difficult for students to understand as they're reading these types of word problems. These comparing situations are characterized by more than and less than. That language is always in these types of problems. One inaccuracy students may have are that they take more than and they want to add right away, and less than and they want to subtract. Another misconception students may have is they see more than or less than and they think automatically, in this comparing situation, I have to subtract. However, let's bring attention back to the three positions. And in a comparing problem, there are three positions: larger number, smaller number, and difference. When solving for the smaller number and difference, students may opt to use subtraction. However, when trying to find the unknown number in the larger number position, they're going to need to use addition, because they're going to take that smaller number and add it to the difference. Again, the language in these problems and the way they're asked can be very confusing, so that's why it's important to solve for this type of situation, or identify this type of situation, and then what position am I solving for. Let's take an example. Sally has 16 coins. Jimmy has 4 more than Sally. How many coins does Jimmy have? We are now solving for the larger number, because Sally has the smaller number of 16 coins, and the difference between Jimmy's coins and Sally's coins is 4 more. We can utilize related equations to help solve this. We might write 16 plus 4 equals question mark, because the unknown is the larger number. Or we might write question mark minus 4 equals 16, because again, the unknown number is the larger number. This situation is directly related to a 4th grade situation when we talk about the multiplicative situation types. So it is incredibly important that students coming out of 2nd grade and going into 3rd have command of this type of problem so that they can relate it to that 4th grade situation. So let's talk about equal groups. And equal groups is the first step in students thinking multiplicatively. They're going to start to use multiplication through fair share and a more additive type of thinking, where if I have 3 friends and I need to give them 2 cookies each, then I'm going to do 1 cookie, 2 cookies for this friend, 1 cookie, 2 cookies for this friend, and that's more of an additive thinking. Ultimately, we want them to transition into consolidating those numbers into groups and patterns so that they can think more quickly through the problem and be able to, fluently, I should say, through the problem and solve the procedural piece. But there are 3 positions in an equal groups problem: the number of groups, the number in each group or group size, and then the total. Now, I'm utilizing a bar model here. However, there are multiple ways to represent equal groups problems. Just like most of the other situations, there are multiple ways to represent these problems. So don't get stuck on whatever models I'm using. It's the situation and the reasoning through and creating that viable argument that's most important. Here's a equal groups problem for you to take a look at. There are 5 plates with 2 cookies on each plate. How many cookies are on the plates? Now, this is a very linear type of word problem. So I wanted to solve for the unknown total in this problem, but I want to bring attention to the plates and the cookies. It's important that students are able to understand which of those are the groups and which of those quantities are the numbers in each group. Please make sure that you're bringing attention to that every time you do one of these equal groups types of problems, because that type of thinking is definitely that multiplicative type of thinking that we want students to have as they're trying to solve for equal groups situations. Arrays are another type of multiplicative situation, and it's very closely related to equal groups. I find that arrays, which are characterized by problems that talk about columns and rows, can easily be applied to equal groups type of problems. I don't have a problem if a student wants to use an array for an equal groups type of problem or an equal groups for an array type of problem. I think the array type of problem helps students to visualize what does this really look like. It helps to give them context of what the word problem is really asking them to solve for, and it gives them a mental representation of what that problem looks like. There are 3 positions to solve for in an array type of problem. Columns or rows, which are your groups, the group size, or numbers in each group, and the total. Let's take a look at this problem here. There are 25 students in the band. We need to put students into 5 rows. How many students are in each row? Students who want to get the answer quickly and not have an idea of how to make sense of the problem may take 25 and multiply it by 5 to get the answer. However, understanding the situation and the position that we're solving for, we have a total of 25 students in the band. We need to put students into 5 rows, which are your groups. So we're looking to find the number of students in each row or group. Students can write up related equations such as 25 divided by 5 equals question mark, that symbol for the unknown. Or if they want to enter the problem through multiplication, they can say question mark times 5 equals 25. Either way, as long as their reasoning is sound and they're making sense of the problem, that's the most important part as they're analyzing the problem and working their way toward a solution. Multiplicative comparisons. This type of situation is closely related to the additive comparisons we talked about earlier. In fact, the 4th grade standard actually mentions the additive comparison and having students understand the difference between the additive comparison and the multiplicative comparison. And here's what it comes down to. In an additive comparison, Johnny may have 5 more than Sally. But in a multiplicative comparison, Johnny may have 5 times more than Sally. It comes down to that multiplicative thinking. There are 5 positions to solve for in this type of situation. There's the smaller number, the larger number, the multiplier or number of groups, there's the difference, and the total. Sometimes this may require, depending on what position you're solving for, it may require 2 steps, especially when you're talking about the difference, trying to solve for the difference, or trying to solve for the total. You may need to bring in that additive comparison thinking for finding the difference, and you may need to join the smaller number and larger number in order to find the total, which is a joining type of situation. So again, these situations don't happen in isolation. Sometimes problems will ask you to build one situation on top of another situation in order to solve for the unknown piece. So here's a problem that helps to demonstrate what the multiplicative comparison looks like. Johnny has a dog that weighs 5 times as much as Sally's dog. Sally's dog weighs 10 pounds. How much do both dogs weigh? Now, there are 2 unknowns in this problem. The first one, we have to find out How much does Johnny's dog weigh? Johnny's dog is the larger number. We need to solve for that first because we're given the multiplier or number of groups, 5, and we're given the smaller number, which is Sally's dog. So that's why we'll take 5 and multiply it by 10, and the related equation would have a question mark, but ultimately we would get an answer of 50. Now, once we understand how much Johnny's dog weighs, we have to go to the second situation. This multiplicative comparison now needs a joining type of situation. How much do both dogs weigh? The number of pounds is the set. We know that one of those parts is Johnny's dog, the larger number, and we know that the other part is Sally's dog, which is the 10 pounds. So we have to join those two weights together in order to find the ultimate solution, which is 60 pounds. And that is the total for this multiplicative comparison. You can see how important it is for students to understand what a multiplicative comparison looks like and the importance of solving for different positions in this problem. Multiplicative comparisons can be a great hiccup for students, especially if they don't have command of the other problem types. As you can see, there are many elements that are involved with this, including equal groups and joining and comparing when you talk about multiplicative comparisons. So let's review. Situation types help our students in 3 ways, and I'm going to relate them directly to the standards of mathematical practice. The first mathematical practice is making sense of problems and persevering through. By students analyzing the situation in the problem, they can better make sense of what they need to do. In the case of 2-step problems, it will help students to persevere. They'll be able to analyze multiple situations when asked a single problem. Students will also be able to take the problem in context and relate it directly to a mathematical concept, and then be able to flip it back into context of solving the problem. Students will also create stronger arguments as to why the math works rather than just giving an assertion and that's just what I got. It's important that students are able to make those arguments and make connections to the work of others. I wish you well as you continue to explore situation types with your students as they become bigger and better problem solvers. Take care, math nerds.